Section 3.3 is on proofs with parallel lines. And you took some notes for me, hopefully, yesterday that involved the converses of some of the theorems that we've been talking about. Okay? Back in chapter 2, you all were wondering, why do we have to know converse? Why do we have to know inverse? Why do we have to know contrapositive? Nothing yet. Just a second. Okay? So, back in chapter 2, we talked about the converse. The converse says we take a conditional statement and we switch the hypothesis with the conclusion. Let's take notes. Okay? So, back in chapter 2, we learned how to switch the hypothesis with the conclusion to get the converse. And that's what we're going to be using today. Yesterday we learned about corresponding angles and the fact that if you have two parallel lines cut by a transversal, corresponding angles are congruent. We're going to abbreviate that as corresponding angles congruent. Is everybody okay with that? I would write this down. Okay? On a piece of paper. On a piece of paper is fine. You don't have to do it in your student journal. Okay. Nope, we're leading into today. Okay? So I would write this down. Yep, this is notes for today. Thank you. Okay? Because we're going to talk about the converse of it today. Okay, the converse of the corresponding angles theorem says if two lines are cut by a transversal and the corresponding angles are congruent, that forces those lines to be parallel. Okay, so that's the converse of it. Alternate interior angles yesterday said if you have two parallel lines cut by a transversal, then the alternate interior angles are congruent. We're going to abbreviate that as alternate interior angles, AIA, congruent. It'll save us a lot of writing. Okay? The converse of that today is going to say that if you have two lines that are cut by a transversal and the alternate interior angles are congruent, then those lines have got to be parallel. Alternate exterior angle theorem was from yesterday as well. It said if you have two parallel lines and they're cut by a transversal, then the alternate exterior angles are going to be congruent. The converse of that is going to say if two lines are cut by a transversal and the alternate interior angles are congruent, then it forces those lines to be parallel. Okay? That's why we wrote all those converses and contrapositives and inverses, so we'd understand where these are coming from. And so we could say the converse of CA, for example, in our reasons for our proofs today.
Why do we even need it to do proofs?
Because it helps us think logically, step by step, methodically, and use reasoning skills. Everybody in geometry is doing proofs. And students of pre-calculus do proofs too. Okay? Consecutive interior angles, supplementary. Okay? That said, if you have two parallel lines cut by a transversal, consecutive interior angles are supplementary. The converse is going to say if you have two lines cut by a transversal and the consecutive interior angles are supplementary, then those lines have got to be parallel. And so our reason for this one we'll abbreviate as CIA. Or the converse of CIA. Okay? We're going to talk about those today. So here we go. Kinds of questions that you'll see today are going to be not so much that the lines are parallel, therefore these angles are congruent or supplementary, but these angles make them be congruent or supplementary, so it forces those lines to be parallel. But you have to be able to justify sometimes. Just like in Algebra 1, we couldn't just say, I can look at that and plug numbers in quickly and decide that x is 7. You had to be able to show your work. This is our equivalent to showing our work. And bankers have to show how a baker. We're preparing you for also making good money decisions as well in your life. We can talk about it after school. Okay, so here we go. We're going to try to find the line, or the measurements that are going to make M parallel to N. Okay? The calendar has our assignments in them. Yep. Okay, so here we go. We have M and N, and notice that they don't have parallel marks. So we're not given that they're parallel. We're trying to make them be parallel by choosing the appropriate values for x that are going to make that happen. Okay? So here we go. What kind of angles are these? Do they have a special relationship? They're not alternate exterior because they're not on opposite sides of the transversal. They aren't alternate interior because they're not between and they're not opposite. They're consecutive something, right? Consecutive exterior, aren't they? But we don't have a theorem for that, do we? We don't know anything about that. Okay? We have consecutive interior, but we don't have consecutive exterior, do we? But what do you know about 72 degrees and this guy right here? They equal 180. Okay? These two are supplementary because they're a linear pair, aren't they? So if I take 180 and I take away that 72, I'll get 108. Okay? Now that I've got 108, I can figure out how these two have to be related to make those lines parallel. So what kind of angles are 108 and this angle down here? Both obtuse. What's their relationship? They're corresponding angles, so they're going to be equal. If we set them to be equal, then those lines will be parallel. Okay, so we say 4 times x minus 5 equals 108. And then I know all of you know how to work the algebra from here. So I'm not going to take the time to distribute, subtract, divide. Is everybody okay with that? Okay. By forcing those two to be equal, or by making them equal, that's going to force those two lines to be parallel. Okay? All right, next one. Here's a proof. Everyone's doing these. Shouldn't be. I'm trying. We've got so many conversations. Come on, guys. Let's just focus. All right, here's our first proof. Okay, this proof says, prove that the alternate interior angles converse. Alternate interior angles converse. Which ones of these would be alternate interior angles? 4 and 5. They're on opposite sides of the transversal. They're between the two lines. So we want these two to be equal. If we can make them congruent, then we can make those lines be parallel. Yes. Absolutely. I'm sorry. Thought you were someone handing me a pass. I sure will. Yep. All right, so we're trying to prove that G is parallel to H. And if we can get, we're starting with 4 congruent to 5, and we're going to try to get G parallel to H. But we can't use alternate interior angles. We're trying to prove that. Okay? Yes, sir.
What is a logical way that you said? Just to look at it,
They look like they're parallel, but we can't just say that they, just because they look like it, that they are. Okay? So, one way to approach this is to say 3 and 7 are corresponding. Good. But we don't know that those lines are parallel, so we can't say that they're equal. But if we can get there, we can say, then we can, that's where we're going. We want to get angle 3 congruent to angle 7. Okay, that's our goal. And once we have them congruent, then we can say that these guys are parallel because the corresponding angle, we can use the converse of the corresponding angle theorem. Not corresponding, but 5 and 7 are linear pair. Good. So 5 is a linear pair with 7. So linear pairs are supplementary, right? Okay. And 3 and 4 are also the same, aren't they? Okay. 3 and 4 are supplementary as well. So we can say the measure of angle 3 plus the measure of angle 4 equals 180. Because linear pairs are supplementary. Linear pairs supplementary. Because they're the same thing. They're going to use the same reason. You can write them as two separate answers or separate lines and use ditto marks. I'm just saving space. Okay? The little quotes. Yep, quote marks or ditto marks. Now, the right side, 180 equals 180, right? Substitution is going to say measure of 5 plus measure of 7 equals measure of 3 plus measure of 4. But they told us 4 equals 5. Well, if 4 equals 5, then can we put 4 into 5's spot? Substitution, I could have used my ditto marks because we substituted twice in a row. Now, why is 3 congruent to 7? Subtraction. We took away this 4 from both sides. And because 3 is equal to 7, then those lines have to be parallel because of the converse of the corresponding angle theorem. The previous proofs, right? Because we have a lot more to work with now. In the previous proofs, we were so limited. We only had angle addition and linear pairs and vertical angles. Now we can work our way around more. Yeah, they were just obvious things, the postulates were. Mm-hmm. All right, one more proof example, and then assignment. You can just watch if you want. If you don't want to take notes. Sir, I'm sorry. Let me go back for a couple more seconds. Okay. So on this next proof, if you just want to watch, I'm recording this session, so you can always go watch it if you need to. Okay? So if it's taking too much time, sometimes you're so busy writing things down that you can't absorb. And I'll also have the notes on my website as well, so you can go back and review the notes. Okay, so here we go. In this diagram, P is parallel to Q. So they've given us our parallel marks to show us these two lines are parallel to each other. And we want to prove that R is parallel to S. So eventually we want to get these guys parallel to each other. Okay? They also told us that 1 and 2 are supplementary. So this one and this one are supplementary. And we're trying to prove R is parallel to S. So if we're trying to prove R is parallel to S, we're working with this and this and this. So our goal has got to be to get these corresponding angles congruent. If these corresponding angles are congruent, then those lines will have to be parallel, won't they? Okay, so we're trying to get 1 congruent to 3, and that's going to force it to be parallel. So there's nothing wrong with working backwards on these. Okay, our second last step is going to say the measure of angle 1 is equal to or congruent to the measure of angle 3. We don't know why yet, but that's going to be our last step. And then because those corresponding angles are congruent, that's going to force those lines to be parallel. Does that make sense to everybody? Okay. So what does it mean? What's our next step? What are we going to do? 1 and 2 are supplementary. What should we say? When they tell us 1 and 2 are supplementary, what should we write? What does that mean? Yeah, add up to 180. So the measure of angle 1 plus the measure of angle 2 equals 180. Definition of supplementary. Okay? What else can we do? Can we get something else supplementary? Three and what? Three and two, right? 3 and 2 have two parallel lines cut by a transversal. And what kind of angles are they? Starts with a C. Consecutive. Consecutive interior angles. Okay? So because angles 2 and 3 add up to 180, they're consecutive interior angles, right? Let's use our abbreviations. Consecutive interior angles supplementary. Okay? We can use that because these two lines are parallel, aren't they? So 2 and 3 have to be supplementary. They have to add to 180. So it's going to be substitution. Good. 1 plus 2 is equal to 2 plus 3. And now why would 1 be equal to 3? Subtraction. We can take away 2 from both sides, can't we? And finally, these lines have to be parallel, because now we have 1 congruent to 3 and their corresponding angles. That forces those lines to be parallel. Converse of corresponding angle theorem. Okay. All right. One thing that you were asked to put into your notes was the parallel lines. What was it called? Parallel lines transitive property. Okay. Parallel lines transitive property says that if you have line A parallel to B and B is parallel to C, or C and C is parallel to D and D is parallel to E and so forth, they're all going to be parallel to each other. So you could say A is parallel to E. And it's just a real quick theorem you should have in your notes. Okay. So assignment is going to be section 3.3 on page 142. Number 1, 2 through 8 even, 12 to 30 even, 33, 35, and 41 to 44. That's due Monday. The homework, you're going to have some theorems to put into your notes from page 150. They aren't due until the 22nd because we're going to spend another day on 3.3. We'll review for a quiz, we'll take a quiz, and then your notes will be due the day after the quiz. So assignment is due Monday, but the notes you can hold off on until the 22nd.
Alright, so how long do we usually like stay on a certain thing?
Usually we do one section a day, but when we get to proofs, we spend 2 days on them. That way you have more practice. For the most part. Sorry, just getting it out of the way.